I have a microphone. Last time I gave a presentation, I had a microphone in my hand and a clicker and was just like driving around and I just thought it looked awkward. So I'm going to be talking about JavaScript testing and all the different ways it can happen and what we can do to get to what I feel is an adequate solution for testing JavaScript applications. So my name is Adam. I am a lead developer at a startup. We're building a CRM, and the front end is architected completely in Ember and completely separate of anything else. So that answers like one of the questions, why should you listen to me? I think you should listen to me, but you can make up your own mind through this presentation, or if you are still concerned, you can just listen to Walter White. If you don't know who Walter White is, he's from Breaking Bad, and he's just a complete badass. So, when we talk about JavaScript testing or just testing in general, there's a lot of things we have to talk about. And what I'm trying to get to is the Holy Grail of JavaScript testing. And by the Holy Grail, I mean something that we can do integration tests and unit tests. We can write the test in JavaScript, when we can execute them in whatever browser we want to, whenever we want to. So when we're developing our application locally, odds are we only really want to pay attention to something like Chrome or Safari, which we know works well. But then when we are, when we want to know we're on CI, we want to test on Internet Explorer, maybe you want to test on mobile browsers, there's a plethora of different build targets you need to check. So that's what I'm trying to get to. So how many of you guys are actively involved in testing JavaScript? How many of you like it? Okay, less, and this just because it sucks. I don't like it either. It's frustrating, but I feel like this is a problem for the community and something that is so important to what we do, and we need it, and it needs to work better. So where we are now is at a problem state because we have many different tools, and some tools work well for some things and just horribly fail at the others. So we can pick and choose these different tools, but it's hard to get them all to work together, which is where the Holy Grail actually is. So what I've run into is like the contractor's problem. It can be the choose any three problem. So cheap, fast, or scalable. Like for example, you can get off the ground writing tests with Jasmine and do unit tests, but what happens when you have 10,000 tests and you have a whole bunch of different modules? You run into a problem. So how did we get here? We got here now because JavaScript is becoming more and more important. I mean, if you just look at the web development landscape over the past like 3 years or whatever, you have things like Backbone coming up and a real shift moving your application into the browser and writing it in JavaScript. This also creates another problem, well, not necessarily a problem, but an architectural change where your user-facing application may be delivered completely separate from your backend. So you have a backend that runs your API, and you have a mobile app, you have an HTML app, you have all these different things. And now you have to treat your front end as a first-class citizen, test it, and put it through a well-known and proven engineering process. So I've been working on this like for a long time, and you can just think about how much the testing landscape has changed in JavaScript over the past couple of years. Now we have all sorts of different tools, and they all are applied a different way. And this is just frustrating. How many of you guys have actually seen Haskell before or tried to program it? How many of you thought it was easy? Okay, 1 or 2 people, that's great. You guys should just be so proud of yourself. I would much rather work on this than work on Haskell. So I'm going to give an overview of some of the most popular testing tools, what they are, and how we can use them for. And I presented these slides to some of my friends just to see what they had to say. And the focus of this talk is about testing JavaScript applications, not just JavaScript that is part of a larger application. Like, say, you have a Rails app and it has some JavaScript that interacts with something on one page, and you need to test that. I don't care about that. I don't work on that kind of stuff. This is for people who are writing like full-blown backbone apps or Ember or whatever. So just complete JavaScript all the way. How many of you guys are involved with a project like that? Anybody? Okay, great. Are you guys using Ember or Backbone? Mostly Backbone, or what? Okay, well then this will definitely benefit you guys. So the first thing that is often mentioned when it comes to like testing JavaScript applications is Phantom.js. And Phantom.js is essentially just a headless browser. You really can't do that much with it. So this is just a quick example of the Phantom.js command line. You can run the Phantom.js command and then type in some stuff like you would be in the console in your browser. And we can use it to do other things. So on this slide, I have an example of just opening a page, then giving an example of how you can programmatically load more JavaScript into the environment, which, as you know, is a huge pain in the ass because you simply cannot do that without writing a new script tag or doing some like other witchcraft to get to work. And then the second block inside that open callback is an example of evaluating code in the remote DOM. Because Phantom.js is just a headless browser, you have the code that it's running and the code that's running in a separate process. So it gives you a way to interact with the other process. So the big benefit of using something like Phantom.js is it's actually a real browser with no screen. Like everything happens in memory, and it's a real DOM. It's a Qt WebKit. It's an older version of WebKit, but it still basically works. So on top of Phantom.js, we have Casper.js. How many people are familiar with Casper.js? Okay, so Casper.js is just a level on top of Phantom.js. It adds some syntactical sugar for interacting with Phantom and the remote page, and adds what I would call a rudimentary test runner. It's not very good. So this is an example of a simple Casper test. And the first thing that should jump out to you about this code is it's not a unit test. This is like an acceptance test or something that the user would actually do. So open some page, type in some things, work on forms, whatever. So there is a Casper.js' primary focus is for writing integration tests. There's a basic API to interact with the DOM, fill in forms, click buttons, do that kind of stuff. And what I found was that it's nice when you have a small number of test cases, but if you have to write like a shitload, you should just abort, and that's what I did. It doesn't work. It becomes cumbersome. It's hard to share code because of the way that the test runner is architected. It's just awkward. But if you need to do a little bit, this can get you off the ground. And also, when you use Casper.js, you can only execute that code inside of Phantom. So if you ever want to, say, run those tests against a real browser, you simply cannot do it. You've already shot yourself in the foot from the very beginning. So the next thing we have is JS Test Driver. How many people have heard of that? Okay. Well, JS Test Driver is made by Google, and it's pretty cool in its own way. So this is just an example from their website, the most basic test you could write. So how it actually works is you have a client and a server. You start the server, and then you can connect other browsers to the server. So say, for example, you could connect Safari, Chrome, Internet Explorer, or whatever. And then when you actually run the test gets sent to the server. The server looks at all the connected clients, and then runs the test on all those, and reports the results back to you. So you can use this to run your tests in different browsers. But this is also good, but also has its own drawbacks. And one of the things is it's kind of hard to set up, and you actually have to have all these other browsers running. And it may work for you or it may not. I personally don't find it so scalable because you have to, first of all, have all those browsers running somewhere and maintain installations. And like it also would work with a mobile device. You could connect your iPhone or an Android phone to the server, and it would work. And it's primarily used for unit testing, which is a common theme in a lot of just testing in the JavaScript community in general. We're not really focused on the entire scope, but just on a small part, because doing the entire thing is difficult and unclear. And now there is Zombie.js, which is kind of like a Phantom.js plus Casper.js combination. How many people have used Zombie.js? Okay. So the code actually looks pretty similar to what you would see with like Phantom. You open a browser and then you can fill in and do some stuff, and you can do some assertions. And the big problem with this is, okay, now all your code and your tests are bound to Zombie. You can't do anything. I mean, you're screwed. And then, as well, you still can't test against a different browser. You're stuck with whatever Zombie is doing. Now, the next tool we're going to talk about is Capybara. And Capybara is primarily used by people like me coming from a Ruby on Rails background, where we would use a tool to interact with the browser running our application. So this is just an example in Ruby of using Capybara to interact with the browser. And it does things like you can fill in forms and click buttons. It also gives you a way to execute JavaScript inside the remote browser, which can be confusing for some people. So for this one, you write your test in Ruby, which you may or may not like, because I know a lot of people like to work in the same language, and I think the Holy Grail is writing your application test in the same language your application is written in, for many other reasons. If, for example, if you write your test in Ruby and your application is in JavaScript, how do you interact with the state of your application inside your tests? You can't do that. And the biggest problem I've seen for many of these different solutions is there's a large cognitive gap for people. They don't understand that there is a process that's running their code in a browser and then the code itself in the browser. So if you're writing a test to interact with your application, if you're using all of these tools, you don't have direct access to your application code. You have to call into another environment to manipulate it. And if you have to do that a lot, that makes your test suite just look really ugly, just callbacks everywhere. One thing about that as well, since the functions are declared in one environment but executed in another environment, the standard JavaScript closure rules don't apply because variables defined outside the function in one environment will not exist in another, which can just be really confusing to people. So the big problem with all of these is that some work for integration test and some work for unit test. There's no way to unify those. And unfortunately, doing JavaScript development, you need a whole bunch of shit to get that going. Like, if you want to do Node, if you want to just type in JavaScript on your computer, first install Node, install C compiler, do all this stuff, then you can have Node. And there's just a lot of crap to do to get going. And unfortunately, there's no way around this now because JavaScript is a browser language. And all of the test code itself is bound to the test runner. And by that, I mean you can only run this code through this other process. So, for example, if you write the test in Zombie, it can only work inside Zombie on top of Node. And some of these things are not CLI friendly. One of the most frustrating things to me about doing JavaScript in general is if I want to open JavaScript, I have to write an HTML page and then put script tags and look at it. I think that's ridiculous. So I want to be able to run tests from the command line like you would do in many other languages. So the Holy Grail for me is something that solves all these problems, or at least takes bits and pieces from all the different things that we have out there and combines them into a decent solution. So the first thing I want to do is remove the dependence between the test code and the test runner. Then provide a single way to write integration test and unit test. I define unit test as something that's just interacting with one piece of code. An integration test is usually something where the entire application is running in the browser. I'm going to click on buttons and do things like that. Stuff that a user would do. Now, locally, you can run the test headless with Phantom, or finally with CI, run it on all the different browsers. And of course, do it with JavaScript. So the first thing to start with is writing your test. And there are many different ways to write your test, but what I found to be the easiest, but sometimes also kind of frustrating, is QUnit. QUnit is great. jQuery core uses it. It's popular. Like, it just works. I think that it's the simplest possible thing that could work. So here is an example of, from their website, a simple unit test. And then below that, I've written just an example of what an integration test would look like with a fill in or a press button, take selectors, and do that kind of stuff. And then the usual assertions. And that like fill in and press API doesn't actually exist. It's something that you would have to write. But you can write it using jQuery. And why should you write it in jQuery? Because that code will run on all browser environments. And it's not bound to any particular thing like some node extension or whatever. Now, the next step is running your tests. Now, this part is, I find, very conceptually difficult for people, because the first thing you have to do is, if you write your test, you have to create this file. And it's just odd, but it's what you have to do in the beginning. So if we create a file that simply has the application code and the test code, we can open that in a browser to see the results. And just think that test.js has QUnit in it, so you know when you open a page with QUnit in it, it's going to load the test. So now we can run this test programmatically from the command line by using Phantom.js. Now, Phantom.js, you can use Phantom.js to open that local HTML page and then inspect the results from QUnit and then print them to the screen. Now that we have one browser, we need to expand out to multiple browsers. And this is now where I'm kind of beginning to theorize and still am looking into. So test swarm is what jQuery uses to test jQuery against every single goddamn browser in the whole world. Yeah. So we can integrate something like this to run our code against all those different browsers. Now, the only reason that this is theoretically possible is because we've written the code in a way that it's not bound to anything else. All the code and the test code itself is just vanilla JavaScript, so it can execute in any environment, such as test swarm. So if you just take the example HTML page and add this test swarm script, then you can open this page from test swarm and look at the results on there. But I don't think that's good enough. What we need to get to is something like this. Like, this is just a theoretical interface to some testing command. So let's say that you have test.js, which is any number of tests. By default, you want to make sure that that JavaScript is working on all environments, so you can run the test. And it will tell you, like, this is much better than doing it some other way. It's programmatically accessible from the command line, so it's simple to understand, at least for developers like us. But where I think this is more powerful is being able to customize the environment based on CI. So if you can customize the build through environment variables. So if you can say, okay, I want to run my test against these browsers only this time or whatever. So if your customer reports a bug on their browser, on their specific browser, you can execute your test the same way you normally would, but against a specific build target, which is great. So is this better? You're goddamn right, it's better. Like, this is so much easier than what we have now. It is, I think it just changes a lot of things. If we can get to something like this, we will undoubtedly increase we'll make all of our products better because we can test them easily. We'll be able to have all the benefits of TDD and build more reliable software for our customers. So, in summary, why it's better is because it's completely browser independent. If you can still open that HTML file on your computer in Chrome, Safari, or on IE6 in your Windows VM or whatever, and it will still work. Or you can send that out to the cloud and run all these ridiculous browsers, and it will still work. And we've written all the tests in JavaScript itself. And since the integration tests, well, let me start over. The last point is the most important, because since all the code is executing in the browser itself, you can hook into your application state from your tests. So let's say that you need to have a way to assert that when I go to this page, fill in this form, and then press enter, then such and such record has been created in my data store. You can just do that. You can just say, app.datastore, blah, blah, blah. Or you need to assert that, okay, the UI acts a certain way when there is no data in the store. You can say app.store.clear, and everything will theoretically just work, depending on how you write your code. But you can access the shared state. And I think that we can solve this problem together. There is a lot of different, we need a lot of different tools to make this work, and they're all out there, but we need, as a community, to integrate them all and make it work. And I've started working on something like something that does this. Not all of what I want yet, but it does give you a way to easily run the test and architect your application. You guys can check it out if you want to. But there is still more. All the things I've talked about only apply to one specific set of circumstances, and that is testing JavaScript in isolation from everything else. So one of the big things that's important is accessing the application state inside the tests. But what happens when you have application state inside multiple places? Like, the classic example is you want to do an integration test between your front end and your API together. Okay, well, now you're in a completely different scenario. So unfortunately, there's just nothing that we can do about it. And why? It's because the software design requirements change the testing system. So if you are in the scenario where you need to test your backend and your front end together, you have to do something else. And odds are, in that particular case, you have your database, right? So the backend has a database. In the tests, you need to clear the database, add more records to the database, make sure the client can get them, which you can't do from JavaScript. So you have to do something else. And then there's all sorts of different edge cases you can get into with things like video or unfortunately Flash or just all different things. But there is certainly a very good base that we can get to. And initially, if you need to make an architectural decision if you are going to separate your application, your JavaScript application out from your backend. That's going to change the way you do everything else. And finally, just make a clear dedicate yourself in the beginning to testing the code. Like, it may be unclear in the beginning, but if you find out how to do it, it will make your life so much easier. And finally, if you want the slides, you can find them here. And that's it.
Are you familiar with Buster.js? Because I have the impression that it solves at least some of the problems or some of the goals of this Holy Grail.
Yes, I am familiar with it, but I was familiar with it before I started working on this presentation, and I forgot what its name was. So I couldn't look it up for the presentation. But I took a cursory glance at it in the beginning, and it didn't seem to do all the things that I wanted. Close, but not all. And the way it did some things, I didn't like. I know those are vague answers because I don't quite remember exactly it from when I looked at. What'd you say?
It's worth checking out.
Yeah. Yeah.
What's just of that was that you should check out Buster.js. So yeah, it's awesome. I can sign that. Any other questions?
Can you please explain more about the test swarm and how you integrated it with your continuous integration?
Well,
some more details, because it's like closed and do not accept registration. So it's
okay. Well, yes, I know that. I'm not sure if it was clear when I presented it, but this was something that I hadn't done yet. But this is what I thought we could, something that we could create to solve all these problems. So I haven't looked into exactly how you could do it, but based on their API and all that stuff, you can. But they do have the source for it. You could pull it down and host it yourself.